All right, let's get started. My name is Samir, and this is my lecture on von Mises stress for DEFBODs. Now, why is von Mises stress important? And so to back up, von Mises stress is a failure method in which we can analyze the point at which a structure will fail. And it is one of many methods, and I believe one of them is called Tresca. There's a whole bunch of them, and some of them are for ductile materials, and some of them are for brittle materials. And I believe von Mises stress is for ductile materials, and that is the focus of today. And like I said, because structures have these failure points and yield points, it's important for us as engineers to be able to analyze and account for said failure points so that we don't have that. If a bridge is designed poorly and it collapsed, number one, engineers are going to get fired. Number two, it's not great for the people who are on that bridge. Right, and so just some general things that are good to know before we get started is that these are principal stresses, right? This is the stress in your x-axis, this is your y-axis, and your z-axis. And this is just good to know for understanding what the stresses are, the principal stresses are. And then two small things is that this will represent the yield strength for ductile materials, and this will represent the ultimate strength for brittle materials. And yeah, and the exact definition is that yielding occurs when the maximum distortion energy is equal to the distortion energy at yielding in a uniaxial tensile test. And so just real quick to draw out a uniaxial tensile test, right? It's pretty self-explanatory, but essentially what happens is you have a cylinder or just an object, and hence the name uniaxial. It is being stretched along its axis. Therefore, why it's called a uniaxial tensile test, because number one, it's in tension, and number two, it is on its axis. So, here is the actual formula to solve for von Mises stress. And this formula essentially signifies like the equivalent von Mises stress or the von Mises stress criterion. And essentially what this number means is that you essentially have to compare this number to that of your yield strength. And if this number is more than or equal to your yield strength, then that means your structure is going to fail. And that's how you use that number. And then something that I thought was cool was just seeing this in FEA and seeing your von Mises stress values. And so this is a piston ring in a car, in an internal combustion engine. And the colors signify the stress levels, right? And if you know anything about cars, then you know that this is where the piston will lie. You have your this is the entire thing is a connecting rod, but you'll have your pin that's connecting your piston and your connecting rod right here. And so when the piston comes down, right, you experience a lot of stress right here. And so that's kind of why I thought that was kind of cool to see that there's a very big stress concentration right there. But yeah, that's my lecture about von Mises stress, and these are my references. Thank you for watching.